Bismillahirrahmanirrahim. Today I will discuss about the antibiotics. So at first I want to what is the definitions of the antibiotics. The antibiotics is the chemical substance that derivates from the microorganism that against the bacteria to kill or inhibit the growth of the bacteria without hair cell. So antibiotics is the two types of antibiotics. There are basically two types of antibiotics. The bacteria works basically two types: the bactericidal or bacteriostatic. So what is the bactericidal? Bactericidal, when the antibiotic kill the bacteria, is called the bactericidal, and when the antibiotic inhibit the growth of the bacteria, this is called the bacteriostatic. The bactericidals are classified into two styles: that broad spectrum and narrow spectrum. The broad spectrum antibiotics are which antibiotics works against both gram positive and gram negative bacteria, and which antibiotics works against only or gram positive or gram negative. This is called the narrow spectrum antibiotics. The broad spectrum antibiotics, gram positive or gram negative. So now I want to show a picture of the bacteria. This is the picture of the bacteria. This is the flagella. This is the embryo. This is attached to the bacteria cell to attack the bacteria cell. And this is the cell of the bacteria, and this is the ribosome, new cytoplasm, and DNA. So basically bacteria antibiotic basically classified into mode of actions. There are on the basis of the mode of action, antibiotic are classified into three types. This is the cell synthesis inhibitor, and DNA gyrase inhibitor, or protein synthesis inhibitor. Now I will discuss the protein cell synthesis inhibitor. This antibiotics also called the beta lactam inhibitors. Beta lactam. These antibiotics contain the beta lactam rings. These antibiotics contain a beta lactam rings. This is the beta lactam rings. So as like the beta lactam antibiotics is the penicillin, cephalosporin, carbapenem. The penicillin likes flucloxacillin, amoxicillin, and cephalosporin likes cephradin, first generation cephradin, second generation cephorexin, third generation cefixime or ceftriaxone, and fourth generation cefepime, and the carbapenem, imipenem, meropenem. So when the antibiotics, and this is the layer of, this is the cell wall. This is the cell wall of the bacteria. If I zoom the cell wall of the bacteria, it looks like that. This is the peptidoglycan. This is peptidoglycan, and this is lipid, and this is cell membrane. So peptidoglycan, this is the outer membrane of the gram-positive bacteria. In gram-negative bacteria, there are two lipid membrane and only peptidoglycan. But in gram-positive bacteria, peptidoglycan is thick, and gram-negative bacteria, peptidoglycan is thin layer. So when the peptidoglycan, if zoom the peptidoglycan, this is we see that this is the sugar amino acid chain and the sugar amino acid chain, amino acid chain, and this is the amino acid chain, and this is the sugar, and this attach the peptidoglycan to from the peptidoglycan, attach each other to from a peptidoglycan. So this enzyme is called the transpeptidase enzyme. Transpeptidase enzyme is this enzyme which is from the peptidoglycan, and this is very essential for bacteria. When antibiotic is administered, the beta lactam bind with the protein binding receptor. When bind to protein binding receptor, the beta lactam ring is activated, and they go to the peptidoglycan and inhibit the transpeptidase enzyme. When the beta lactam antibiotic inhibit the transpeptidase enzyme, the peptidoglycan ring is back down, and the bacteria is killed. The bacteria must be killed. This is the function of the beta lactam antibiotics. But now in many situations the antibiotics is going to be resistant. So why antibiotic is going to be resistant? This is why the beta lactam, we know that the beta lactam bind with the protein binding receptor and the inhibit the transpeptidase enzyme, but when antibiotic sometimes sometimes beta lactams, sometimes peptidoglycan or the cell wall of the bacteria secrete the transpeptidase enzyme. This transpeptidase enzyme break down the cell wall. This transpeptidase enzyme break down the beta lactam ring. When the transpeptidase enzyme, beta lactamase enzyme break down the beta lactam ring. When the beta lactamase enzyme break down the beta lactam ring cannot be activated and they cannot kill the bacteria. So now I will discuss the DNA gyrase inhibitor. When the DNA gyrase antibiotics is like as the protein synthesis inhibitor or the DNA cell synthesis inhibitor, protein synthesis inhibitor, and amino acid synthesis inhibitor. আরেকটা হচ্ছে amino acid synthesis, amino nucleic acid synthesis inhibitor. Nucleic acid synthesis inhibitor. Nucleic acid synthesis inhibitor is nucleic acid and protein synthesis inhibitor, macrolide and tetracycline. Tetracycline likes the doxycycline and macrolide erythromycin, and DNA and protein synthesis inhibitors likes the nucleic acid synthesis inhibitor likes the coenzyme group ciprofloxacin, levofloxacin. So now I will discuss about the protein synthesis inhibitor. Protein synthesis inhibitor inhibit the protein synthesis, then the bacteria cannot be synthesis the protein and cannot be growth, so bacteria must be killed. And nucleic acid synthesis inhibitor, when the nucleic acid synthesis inhibitor applied to the nucleic acid, that the DNA gyrase or the DNA application not be applicated, DNA not be replicated, the bacteria is killed now. So here today now I want to that's why beta lactam rings. Today the lecture is finished now. Yeah, thank you.